Hello and welcome back. Today we will just prove that f of the image of a union of two sets is equal to union of the images. Whenever you are proving two sets are equal, the way to prove it would be to show each one of those two sets is a subset of the others, and then that will prove that these two are equal. So that's the idea. So first of all, we are going to prove that left-hand side is a subset of right-hand side. So we'll be proving this direction. In order to do that, we'll just start with an arbitrary element in left-hand side and then show it is in right-hand side. Then that will show every element in the left-hand side is in right-hand side. So let y in f of A union B be arbitrary. So now we want to show this y is in right-hand side. Now, let's look at the definition. What does it mean for something to be in the image of A union B? So this means that there is something in A union B. If you apply f to it, you get y. So there exists x in A union B such that f of x is equal to y. Okay. Now what do we do with this x? Now this x is in A union B, so that means this x is in A or x is in B. Now if x is in A, so if x is in A, so what is f of x? Then f of x is in f of A. Now what happens when x is in B? If x is in B, then f of x is in f of B. Okay, so there are two cases, either x is in A or x is in B. If x is in A, then f of x is in f of A, but f of A is a subset of f of A union f union B. And f of B is also a subset of f of A union f of B. So if f of x is in f of A, then this implies f of x is in f of A union f of B. And the same thing here. This also implies f of x is in f of A union f of B. But f of x is the same thing as y. So what it shows is that if y is in the left-hand side, then y is in the right-hand side. So that means every element in the left-hand side is in right-hand side. So the left-hand side is a subset of right-hand side. Okay, that's one direction done. Now we need to do the other direction. Now we need to show the following. F of A union f of B is subset of f of A union B. So this is what we are trying to prove. Okay, how do we do this? We start with something here on the left-hand side and then we show it in the right-hand side. So let y be an arbitrary element on the left-hand side. Union f of B be arbitrary. Okay, now we want to show it is on the right-hand side. How do we do that? We just unpack the definitions. So this means, so what does it mean for something to be in union? It means f belongs to f of A or y belongs to f of B. Okay, so we have two cases, so we work with both cases. And we will show that on both cases it is in f of A union B. Okay. If y belongs to f of A, then what does that mean? So this implies there exists x in A such that f of x equals y. Okay, but X is in A, but A is inside A union B. So this implies X is in A union B. This implies f of X is in f of A union B. Okay? Now, similarly, if Y is in f of B, you just have the same argument. I will do it this time, but once you are fluent, you can just start saying, oh yeah, I guess that the case is exactly the same, we just replace A by B. Anyway, and there exists X in B such that f of X equals Y. Then that implies that if X is in B, then it's inside A union B, because B is inside A union B. This implies f of X, which is equal to Y, is inside f of A union B. Either way, we started with an arbitrary element Y in f of A union f of B, and we showed that it is in f of A union B. So this does the other direction. If we look back, we've proven the left-hand side is in the right-hand side, and over here, we proved that the right-hand side of our original statement is in the left-hand side. Therefore, these two are the same. That's how you do this. Do have a go at other questions, and then I will see you in a future video.